Hello and welcome to the very first tutorial in a new series in SolidWorks Mold Tools. This is tutorial number 176 in general, and we will talk about the mold tools, where to locate the commands, and which manufacturing processing are using the mold tools. And then we will have a quick review for the surfacing section in the mold tools and how they are related to the mold tools. And then at the end, we will have a look at some important definitions in molding, draft, parting line, and shrinkage. So go to SolidWorks and start a new part. Okay, so to find the mold tools commands, go to Insert, and here you will see molds, or an easier way here in the tabs. Right click and check mold tools, and here you will get the mold tools sections or the mold tool commands. So if you have a look at the mold tool commands, you will see there are 4 sections. The first section is related to surfacing. Most of these commands we talked about in the surfacing section, and here are the analysis section. The third section is drafting and parting line and scaling, and the last section. This is also an advantage of the SolidWorks software. It has mold tools commands, so it makes working with molds easier. As we know, making molds is a complicated process, and the molds are used mostly in injection molding processing, manufacturing process, mostly for plastic, and also in casting. Also, there are some molds or dies for forgings. So before going to some molding terms definitions, we will have a quick review for the surfacing sections. And I will put a link below for the surfacing tutorials which we talked about before. So let's go to the top plane and we will make a very simple block. So let's make it of a cube, and here make a dimension of 200 and extrude it in 2 directions. Go to Features, Extrude, Mid-plane, and extrude it 200 steel. So let's add a steel. Also, there are some molds made of aluminium. So we have a very basic block without any separation or any parts. Go to the mold tools and we will see how to use the planar surface. Go to the sketch one, show, select planar, and select that sketch. Click OK. So you just created a separating surface. Hide that. You will see there is a surface. So this is one way to use planar surface. And also, if you would like to, let's show again the block. And if you would like to have the planar surface not in the middle, like shifted 1 centimeter or few millimeters above the center, you can go to the offset, select the planar surface and make it 20, for example. Click OK. Hide the block again. You will find a second surface which is offset. Show the block again. Rolled surface. For example, if you don't need all the time to hide the block and need to show the surface, let's hide that sketch because there are 2 surfaces but they are not shown. You can go to rolled surface, and here are the options. For example, you can select the edge of that surface and the rest of the surfaces the rest of the edges. So here you have a 10 millimeter. You can increase it. You can make it normal to the surface or tap it to vertex or sweep. So we stick on the first option. We can make it just straight. And when we are done, click OK. So now you have the surface is clear, and it is clear there is a surface separating the block. And fillet surface, for example, if you would like to have a different shape than the cubic shape or the square shape, you can make a custom surface. You can just, for example, create that surface on the top of that shape and draw a circle, give it a dimension of 350, go to surface, go to the mold tools, exit from fill surface, select, so you fill it that surface, which is a circular surface. So I'm going to suppress that circular surface. So it needs surface. For example, we have created that separating surface, but when we generated that with the rolled surface, we made one for the rolled and a second for the main. And here is the offset, which we can suppress to make it clear. So that offset, and here we have only two surfaces, which can be better if we made them in one single surface. You go to neat surface, you can select the rolled and the planar surface. Click OK. You will notice that now we have only one single square surface. So this is a quick review for the surfacing commands in the mold tools, and later on we will see how we can divide the block and make it two parts and adding parting line. So now let's talk about some molding terms. So the first term we will talk about is the draft and why we need a draft. So the draft definition, according to the Wikipedia website, is the amount of taper for molded or cast part perpendicular to the parting line, and it is measured by degrees, and we will show this what is exactly mean with draft. And you may already know what is the draft because there is many commands in SolidWorks we used in the solid features. We have the draft, so there we are creating an angle. And why we need the draft? It makes it easier to extract the parts, the injected part or casted part from the mold, and that will also increase the mold life. As we know, the molds are quite expensive. And the next term is the parting line. So this is the parting line where the draft is calculated. So we made the part, as you remember in the beginning here. So the parting line should be this line over here, which is separating the mold. Also, draw the parting line here, so we can draw that separating line between the two sides of the mold, and here we can draw so here I made a very simple shape. If you see the line, the straight line over there, that can be the parting line, and the top side over here is the upper side of the mold, and here is the lower part of the mold, and here is the casted or the injected product. Let's say it is a cup over there. So the draft is, if you see the angle, also the draft can be positive and negative. Here, for example, this side, and we said this line is the parting line, and here can be a positive draft, and this side is a negative side. So if you imagine the product over there with a draft, it will be easier to be extracted from the mold. So this is a positive draft, and here this side is a negative draft. So here again we can see this is the parting line, and here is, if we make a straight line, and here is the draft angle. So one last term is shrinkage. Once we extracted this cup from the mold, so this is the actual size of the mold, but after cooling it will get smaller. For example, it is a plastic or a metallic, so that is a very basic. So as we know, the material are shrink when it gets colder. If the plastic which is used will be shrinking with 40%, so the mold should be designed 4% larger than the actual product